In our next example, we have someone that had a lot of time on their hands because they had a piece of wire and they decided to bend it in the form of a sector for some reason. And they're telling us that the length of wire is 40 centimeters and it's bent in this shape. And the angle is in radians, so theta radians. And the total area they're also saying is a square centimeters. But we want to firstly express theta in terms of r. So there's a type of a relationship here with theta and r. Yeah, so obviously we know it's a 40 centimeter perimeter. So this length plus the arc length plus the other radius should give us 40. So I'm going to start off with 2r because that's, the radius plus the radius. And for the arc length, I can just take I'm just going to add the radian angle times the radius. Pretty straightforward, just the normal arc length. I'm sure that's in a formula sheet somewhere, but that will just give me the arc length. So I know this, the radius plus the arc will add up to 40. Add up to 40. There we go, adding them up to 40. And now I have to express theta in terms of r. So theta should be my subject. So to get that out, I'm going to, let's say, factorize, and then I'm left with 2 plus theta. And that is going to be equal to 40. I'm going to divide by the radius on both sides. So if 2 plus theta is 40 over r, and then just subtract 2 on both sides. So I have 40 over r minus 2. Yeah, I think that's good enough. It can also be written as one fraction, so I can put do something like this, add an r and an r on both sides. So this would be able to write this as 40 minus 2r over r. But yeah, either or, both of those are the same. Next, they're telling us show that the area is 20r minus r squared. So the area of a sector, let's just write that formula down. So the area of a sector would be half the radius squared times the angle in radians. In this case, theta. And I need to show, okay, so there I have the area and I only have one input value, so to speak, so it's only a radius. So this theta should actually be turned into a radius, and luckily I know how to do that. I'm just going to use this. So I'm just going to substitute this in, r squared, and that's going to be 40 over r minus 2. And just distribute this. So a half times 40 is going to be, well, 20. And that is basically an r squared over an r. So it's just going to be r. On the right track there with 20r. And then minus half times 2 is going to be 1. I don't really have to write the 1. And then r squared. So I'm just going to make it r squared. Cool. Proven. I'm just going to write this here. A is equal to 20r minus r squared. Although it's written there, I probably didn't need to write that. But anyway, so we proved that. That's fine. Next part of our question is they're saying find the value of r, which there's a stationary value of a. So when I hear stationary point, then my first thought is I have to derive and get a stationary point, make the derivative equal to 0. So I'm going to take that and derive it. So the change in a with respect to r, and the r is just going to be a 20 minus 2r. Pretty simple. And this should be equal to 0 because it's a stationary point. And then I'm left with 20 is equal to 2r, and then r is going to be 10. Find the value of r, so that's fine. Oh, that's it. Okay, stationary value. Okay, now find the value of r for which there's a stationary value of 8. Okay, great. That's what we did. know it's a stationary point because the derivative is equal to 0. And now for the next part is determine the magnitude or the size and the nature of the stationary point. So to get the the nature we'll do by doing the second derivative, but let's just do the magnitude first. So I know r is 10, so all I have to do is I have to substitute 10 in here, so 20 times 10 minus 10 squared, and that would be 200 minus 100, which would just be 100. So the magnitude is 100, and our units are square centimeters, as I said. And the nature, we have to just derive that. So d2a over dr squared is going to be, well, the 20 will fall away, and then we'll just be left with minus 2. So because we have a minus, that looks like it's that shape. So the nature of the stationary point is a maximum point. So we have a maximum point where the radius is 10. Yeah, pretty simple.